Hello, fellow chemists. Jolly here again. I wanted to do a little brief discussion on what makes a good bonding place or how to make bonds in those Lewis structures. Alright, so again, this is one piece of the overall big picture, but if you were to get to a point with, let's say you had a carbon with its 4 valence electrons, let's say you had a sulfur with its, with its 6 valence electrons. Let's do a chlorine with its 7 valence electron. How many good bonding places are there? Now, when I say good bonding place, I mean a lone electron. So carbon has 1, 2, 3, 4 good bonding places. Okay. Sulfur has 1, 2 good bonding places, and chlorine only has 1 good bonding place. Now, this is not limited. You could, depending on the atom, and you will get this instinct later on, depending on the atom, I could split those up. Okay, I could split those up and I could create this. 1, 2, 3, 4. Notice all I did was unpair the electrons. I'm the one that paired them in the first place, so I can unpair them. But if you ever unpair these, okay, if you ever unpair a lone pair on the central atom, that usually means you're expanding. And you are only allowed to expand on certain atoms. Can sulfur expand? The answer is yes. But do you notice I went from just 2 good bonding places to 4 good bonding places? So you are allowed to unpair electrons. But remember, in doing so, that atom has to have something special that goes along with it. All right, let me clear this screen away, and let's do just an example. All right, let's do a bonding example. Let's say we had a carbon, and we had an oxygen, and so my formula is CH2O. All right, so I first put my carbons, and then I connected my oxygen to it. All right. Do I still have loners? Yes, I do. I have 4 loners, but I only have 2 atoms left. So for two reasons, I only have 2 atoms or substituents left. And when there is an adjacent electron on both the central and on the adjacent or the one next to it, I call that screaming. It is screaming at me to make a multiple bond. So immediately, if I saw that, I would immediately do that. Now how many good bonding places are left? Are there any loners? Yes. There's 2. Well, how many things do you have left to put on it? You have 2. And so I would put the 2 hydrogens right there. Okay? So remember, we like a logical progression of where to put those electrons, but they're not fixed in that spot. They don't have to stay right there. All right, let's try another one. Let's try a sulfur. All right, so let's say we had, no, you know what, let's do a phosphorus. PCl5. Who should go in the center? It should be the phosphorus. How many valence electrons? It has 5. How many good bonding places does it have? 3. Well, how many things am I trying to put around it? 5. So remember, I'm the one that put the electrons, so I don't have enough bonding places, so I'm going to unpair one of them. Get rid of those real quick. So 1, 2, 3, 4. And instead of pairing it up, I'm going to put it like that. Well, how many good bonding places do I have now? I have 5. How many things am I trying to put around it? 5. But remember, if I unpair it, that usually means I'm expanding. Can phosphorus expand? The answer is yes. And then I would put the chlorines here. All right, do I have any loners left? No, so I would go on to the next step. So, in summary, What is a good bonding place? It is a lone electron. Okay, so a bonding site is equal to a lone electron. You can unpair electrons if, okay, that atom can expand. And of course, you are more than welcome to move electrons around. All right, there's going to be other situations that, just are a little bit tweaked off of this, but that gives you a good basis for what do I do when I make a bond and what are my bonding sites. All right, good luck. Jolly out.